Hey everyone, welcome to this explainer. I am so thrilled you're here today. We are tackling something incredibly foundational, yet honestly, it's so often overlooked by folks rushing to build the next big thing. We're diving into AI Solutions 101, specifically focusing on your workstation and lab setup. The core goal today is simple but absolutely crucial. We are going to build a repeatable, protected place for you to learn and build AI. Because without this solid foundation, I promise you, even the most advanced models in the world won't save your project.
Okay, let's just jump right into our agenda. We're going to cover 5 key things today. 1, the hidden AI failure. 2, setting the right boundaries. 3, local versus cloud realities. 4, building your minimum stack. And finally, 5, the non-negotiable safety rules.
So picture a gorgeous, modern, cloud-connected workstation. Looks amazing on the surface, right? But the physical hardware is really just, well, it's just the surface. What actually matters is the hidden architecture underneath, the disciplined, repeatable sandbox that makes real AI development possible.
All right, Section 1, the hidden AI failure environment versus model.
Let's shatter a massive misconception right out of the gate. When your code suddenly breaks or the output is just total garbage, our very first instinct is to blame the AI model, right? We think, oh, the model isn't smart enough or it's hallucinating, but actually, very often it's an environment failure just wearing an AI mask.
So, what are the actual culprits here? Well, it's usually boring administrative stuff. You know, the classic, it works perfectly on my machine but crashes on yours syndrome because of incompatible dependencies. Or maybe a model just totally maxed out your local memory. Or a cloud notebook fundamentally can't access your regulated data. And the absolute worst, committing an API key to a public repo. Yikes. All this just goes to show your first architecture doesn't need some massive GPU cluster. It literally just needs a disciplined boundary.
Which brings us to Section 2, setting the right boundaries. 3 pillars of a finished environment.
Pillar number 1, placement. Basically, where is your AI work actually running? Are you doing this inference entirely on your laptop, or is it sitting on a remote server somewhere? Knowing exactly where your computational work lives is the absolute first step to controlling it.
Pillar number 2 is isolation. What's the exact boundary keeping your AI project from just wrecking the rest of your system? Without isolation, you're looking at total chaos. If your project secretly updates a system-wide Python package, it might break a completely unrelated app. We absolutely need a solid wall between our experiment and the host machine.
And pillar 3, repeatability. Ask yourself this, if a collaborator tried to recreate your exact setup from scratch tomorrow, could they actually do it? Because if they can't, your environment isn't really finished. It's just a temporary, fragile hack.
Think of this like a sandboxing spectrum. It's all about matching the boundary to your actual needs. A simple project folder is great for organizing things, but it gives you zero dependency isolation. Step up to a Python virtual environment, your .venv, and boom, your packages are isolated beautifully, but you still aren't isolating the OS. For totally repeatable runtime stacks, you have to move up to containers. The big takeaway? Stronger isolation is incredibly powerful, but it definitely brings higher setup costs. You want the smallest boundary that actually gets the job done.
All right, Section 3, local versus cloud realities, making the architectural decision.
There is a huge tug-of-war here, and we need to bust some myths. People assume local automatically means secure. It doesn't. Your machine can get lost, community apps can bring in nasty supply chain risks, or you might accidentally expose local services to the whole network. On the flip side, people assume cloud means easy and convenient. No way! The second you go cloud, your data leaves the device, the billing meter starts running, and you're totally at the mercy of your internet connection.
Because of those tough trade-offs, the most practical path forward is almost always a hybrid one. It's a deliberate progression. First, you test your code and prompts locally on a cheap sandbox. Then, you step up to a hosted evaluation to compare with heavier models. Next, layer in enterprise test controls. And finally, move to production. The golden rule to remember? The application and the AI model do not have to live in the exact same place.
Moving right along to Section 4, building your minimum stack. The blueprint.
Okay, let's get into execution. Here are your first 4 essential moves, and the order definitely matters here. First, validate the minimum stack you already have, like your browser, Git, and Python versions. Second, create a dedicated workspace folder. Third, initialize a Git repository right away to track your progress. And fourth, isolate your Python packages using a virtual environment. And hey, quick tip from the sources. A failed command during this validation phase is a question you need to go research. It is not a cue to just blindly install something new. Be deliberate.
Now for the final 3 moves. Step 5 is absolutely critical. Protect your credentials using placeholders. Step 6, you have to make a choice. Pick just one sandbox. Maybe it's Docker, maybe Codespaces or LM Studio. The whole point is to choose one path you can actually explain rather than just hoarding maximum tooling. And finally, step 7, write down your exact setup steps directly into your README file.
To really keep things locked down, you're going to create a file called .inv.example. This will hold fake placeholder text, like literally replace me, for your API keys. You can totally share that file safely. Then, use a .gitignore file to completely block your actual secrets and your bulky virtual environment folder from ever touching Git. Bottom line, keep your examples in version control and keep your real secrets out of it.
Finally, Section 5, Non-Negotiable Safety Rules, Protecting the Lab.
Setting up the tech is one piece of the puzzle, but operating it safely is the whole shebang. Here are your non-negotiable rules. 1. Stick to approved data. Use synthetic or public data for practice, and absolutely keep real organizational secrets out of your prompts. 2. Lock down those credentials. Never ever commit real API tokens. 3. Limit your exposure. Do not carelessly expose your local model server to an untrusted network. It's like leaving the front door to your computer wide open. And 4. Verify the supply chain. Treat community AI apps as third-party software that needs real scrutiny, because containers are great, but they don't guarantee perfect security.
I want to leave you with this really provocative thought from the source material. Where intelligence runs is part of how intelligence is governed. So I challenge you to ask yourself today, what is the absolute smallest, most isolated, viable environment you can build right now to support your work? Start small, isolate everything, protect your keys, and build up from there. Thank you so much for joining me for this explainer, and hey, happy building.